in the air, so we really have enough oxygen available. In fact, PO2 levels are normal. Okay, this is why people with carbon monoxide poisoning have pink or cherry red skin or fingernails, because the PO2 is normal,
But not all the hemoglobin.
but the saturation, which is where most of our hemoglobin is being carried, is not saturated. And that's where we can't live with just the amount of oxygen we have dissolved in the plasma. Okay? In fact, I was telling the morning class my master's degree I got from Southern California at Loma Linda University, and I was in the anatomy department where I got my first love of comparing anatomy and physiology. And they were working with pregnant guinea pigs, the fetal physiology unit, and measuring the diffusing capacity. And they had the pregnant guinea pigs exercise 45 minutes a day. And just before term, the mothers were given enough anesthesia, a fatal dose of anesthesia, so both they and the babies were knocked out. But before they died, the measurements were made with the oxygen diffusing capacity, and then a glutaraldehyde or formaldehyde, a fixative, was introduced into the uterine arteries at physiological pressure, diffused into the placenta, and fixed the placenta. And then it was sectioned and stained and photographed, and then a computer science was used to trace around the fetal blood vessels. And the computer converted that to the number of blood vessels and the overall surface area. And they found that the mothers that exercised 45 minutes a day had decreased diffusing capacity. It was almost funny that one of the researchers was asked to fly to Canada and give a talk about his results. And I think that the organizers of the seminar had just read exercise and maternal diffusing capacity, and they were thinking it was a good thing, and he gets up and says they had a decreased diffusing capacity, and they were like stunned. I think they were expecting him to support women should go out and run. And he was like, no, I'm not saying you shouldn't exercise if you're pregnant, but you should start exercising when you're pregnant. If you're already doing it, that's fine, but you shouldn't start a running program of 5 miles a day, when you're 6 months pregnant, because it causes a movement of the blood to the skeletal muscles. Well, so there's a decrease in diffusing capacity. When they looked at the anatomical structures, there was a decrease in the number of fetal blood vessels and fetal surface area. So they repeated the experiment, except, well, with some changes. Instead of having the pregnant guinea pigs run a treadmill 45 minutes a day, they put them in a room, all their cages in a room that had 12% oxygen instead of 21% oxygen. So these individuals, these guinea pigs, had an increased diffusing capacity, and the study of the placental structure showed an increase in the number of blood vessels and surface area. So when I got there, I did the anatomical study of the placenta with guinea pigs that had been in a room with carbon monoxide. And the expectation, in fact, was really kind of funny that the guy in charge of the whole lab, not just the experiment, was not on my committee. So when you do a master's, you write your thesis. Doctoral paper is called a dissertation. You write your thesis and then you defend it. And you have a committee of 3 or 5 people, and guests can come, but they're not supposed to ask questions. They can just listen. And so you're in front of these people, and you're being asked questions, some easy ones and some more difficult ones, to explain your results. So this director of the entire lab came as a guest, but inserted himself into asking questions. I was like, he's not supposed to do that. And my major professor was like, you should be flattered that he's here. But he really shocked me because he said, without any warning before the meeting, he said, well, you must have done your experiment wrong, because with the carbon monoxide, the results were no change in diffusion capacity and no change in the diameter of the fetal blood vessels. And he said, well, the experiment was wrong. You guys didn't, you should have gotten an increase in diffusing capacity. You should have gotten an increase in the number of fetal blood vessels, because that's what we got with hypoxic hypoxia. And it just startled me. I had been taught all through science that you don't go into an experiment with a preconceived idea. you do the experiment and then you look at your results and try to develop theories by how you got the results. And so I don't know if he was setting me up or if he actually believed that I had done the experiment wrong. But in recognition of these factors, I came back at him and I said, well, even though the total amount of oxygen available to the fetus was low, I said there's one factor that didn't change. Saturation is low. The amount of oxygen that the fetus gets is low. However, if you look at PO2, that's normal. And maybe that's the factor that triggers the structural changes in what's available to the fetus and why the vessel numbers change. So yes, the fetus got less oxygen available to it, but maybe it didn't change because what triggers that is a change in PO2 rather than the available oxygen to the fetus. That was 1981, and I still remember to this day being shocked that he would assume that he would have a preconceived idea of what the results should have been. And like I said, maybe he was just trying to set me up and see what I would give him as an explanation. So with carbon monoxide poisoning, we have adequate oxygen in the lungs. There is no problem with the respiratory membrane. There is no problem with, since we have adequate oxygen in the lungs, we have adequate PO2. We have a normal PO2. But because of carbon monoxide binding, replacing oxygen on the iron, we have a decreased saturation. Okay, our percent saturation is low. All right, and then any other factor that's going to shift our oxygen dissociation curve to the right. Now, carbon monoxide shifts it to the left, okay? But any other factor that's going to shift it to the right, meaning it can't, this would be effective not at the tissues, but when we see it at the lungs. For instance, what does hydrogen ion do? It shifts it to the right. That is what we want to happen when we're in this area. But if we have acidosis, if we have high numbers of hydrogen ions in the blood when it's in the lungs, there is the possibility, not as much as when it's in the tissues, but there is the possibility that it cannot get saturated. Okay? So when we shift that to the right, let's look at carbon monoxide here. So it tends to even out up here at these levels, but it's going to have a decreased amount of saturation. If we have a lot of carbon dioxide, it can't become as completely saturated. The effect is not as strong as on the steep portion, but it does have that effect on the flat portion. Okay, stagnant hypoxia. Think of stagnant as blood flow. All right, so stagnant hypoxia is enough oxygen is in the atmosphere, enough oxygen is in the alveoli, no problem with the respiratory membrane. We have enough red blood cells. We have enough oxygen dissolved in the plasma, so all of those factors are normal. But this is the tourniquet around the arm, okay? Or the blood clot in the lung, or a weak heart. So there's some problem with the cardiovascular system that's not moving the oxygenated blood through the body. So oxygen is there, it's just not, there's a transport problem. So back to our Berlin relief, we have all the food, we just don't have the planes. Okay? Well, we have all the food and we have all the planes. It's just maybe there's a weather, there's a storm, the planes can't fly. So there's some problem in getting the oxygen to the tissues. And then the third one is poisoning. Now, carbon monoxide is a poison, all right? But when we talk about histotoxic, it's a poison, histo meaning tissue. So histotoxic hypoxia, nothing wrong with the blood vessels, nothing wrong with the alveoli, nothing wrong with the air. It's the cells themselves. So potassium cyanide affects the enzymes that the cells use, how the cells use oxygen to make ATP. So those of you that had me last semester, we did a case study in one of the sections on the cyanide poisoning of the dog. All right, and so in the venous blood, if oxygen can't be used, we're going to have more oxygen in the venous blood and less CO2, right? So they're not making glucose, they're not breaking down the carbons and releasing them as CO2. And so they're not making the CO2 and they're not using the oxygen. And finally, with hypoxia, let me change that one back to hypoxia. This has to do with the oxygen, either the oxygen available to the blood, or it has to do with the respiratory membrane, with the alveolar structure. So high altitude is going to affect the oxygen available to the blood. Here, increased diffusion distance, that's the alveoli. Okay. So remember I was drawing some diagrams. I said that obstructive pulmonary disease would look like this if this was normal. You had a wide airway. This would be normal. This would be obstructive. And restrictive would have a blockage of pneumonia, of fluids. Okay? Something like pulmonary fibrosis, where you have a thickened membrane. You're going to have an increased thickness in the wall, so increased diffusion distance because of the wall changes. It's going to take longer, so even though we have normal alveolar PO2, we're going to have a low PO2 in the blood. Okay, so in that case, our hematocrit and hemoglobin are normal because there's nothing wrong with our red blood cell production. We don't have anemia, but we're going to have low PO2, and because of the low PO2, we have a low hemoglobin saturation. So in any of these four conditions, there's still the end result, the cells don't have the oxygen needed to function. The next couple of slides look at high altitude and acute mountain sickness, or AMS, is another form of altitude sickness. These numbers here I wanted to explain a bit for you. This is 100% oxygen would be 160 millimeters PO2 of the atmosphere, or in the blood, 100 millimeters PO2 of alveolar PO2. Okay? Remember, 21% of the air is oxygen at sea level. It would still be 21% here. This is the available oxygen that's decreased, not its proportion of overall air. So when someone says, well, you have half the oxygen available, it's not that it's dropped to 10% of the proportional component, it's that it's still 21%, but there's half of everything. Okay? So when you take a breath of 500 mils of air at sea level, let's just make up the numbers, we have 160 molecules of oxygen in that breath of air. Okay? And then let's say you go up to 18,000 feet, you would have 80 molecules of oxygen in that air. So the proportion is still the same, but the numbers have dropped. You would only have, 500, you would only have whatever half of 560 is. So you can kind of convert this within plus or minus 10 to alveolar PO2, or arterial PO2. So if at sea level your arterial PO2 is 100 to 104, all right, then at these different elevations, say you would have a PO2 of 66, or a PO2 of 50, or if you're up Mount Everest, a PO2 of 33. Now, I was looking up, trying to find the actual formula for converting elevation to PO2, and it's a little complicated because it involves water vapor and temperature changes. It's probably more like 28, PO2 of 28 at Mount Everest, because I found some computerized calculators that would do it for you, but it's close enough that you can just convert those percentiles effectively to millimeters PO2 for arterial. All right, so when we look at altitude, obviously there are effects on the body with less oxygen. this has way too much information. This is more for you if you want to look at it online. Talking about characteristics and temperature effects. Developing acute mountain sickness or altitude sickness is not a factor of being fit, right? You can have someone that is a SEAL member and very physically fit develop altitude sickness, and somebody who's overweight not. So it's not a factor of the strength of the heart or the capability of the body's production of red blood cells. Symptoms, has anybody had altitudinal sickness?
My
Anybody?
boyfriend.
Huh?
My boyfriend.
Your boyfriend, and you were fine?
Yeah, and he's the fit one. Because we climbed Mount Whitney last
Oh, did
summer,
you? Yeah?
and we did it in one day, and so it was like, we didn't get to acclimate very well. But I took pills for the week ahead of time and drank extra water, and so that's supposed to solve you. He didn't do that. So
He didn't do that?
he was hallucinating.
Was
and
he
throwing
really?
up.
Wow.
Yeah.
That's in the
And
moderate.
then he was fighting
Yeah,
with
right,
me
it's-
because he thought that, he
He
was
was
trying
fine?
to convince me that what he was seeing was there and that I was crazy.
So,
scary, though.
you came down the same day, or did you
Yeah,
make it to
we
the
went
top, or did you turn around?
No, we
How
went
far up did he develop the symptoms?
around, I want to say 11,000 feet.
Okay? So
And-
typically, up to 8,000 feet, you're okay. All right, when I was looking up I was trying to find some additional, I was looking for those equations to figure out PO2, and there's a site that has these calculators, and it's trying to increase awareness of some of the significant symptoms of acute mountain sickness. And so it's asking for individuals to send in experiences, and one of the more recent was death that occurred in Peru in May of last year. A Canadian man, who was in his mid-30s, and his father, who was in his mid-60s, was a retired high school teacher, and they had gone to Peru for a month vacation, and while they were there, had decided to do a 3-day trip climbing one of the canyons. Now, it's a canyon deeper, twice as deep as the Grand Canyon, but it's at altitude, all right? So they were at about 2,600 meters. A meter is 39 inches, so if you multiply 26 by 3, it's somewhere between 7,800 and 9,000 feet, trying to do the math in my head. And it's unusual to develop a severe mountain, there you go, a severe mountain sickness as he had, but the day before, on the descent, his dad had complained of, was coughing, and had complained of tightness of the chest, never developed the hallucination components. On the climb back up, he was a few 200 feet ahead on the trail, and he suddenly collapsed, and they weren't able to revive him. And the autopsy showed he had developed pulmonary edema, which is the severe. It's called HAPE, for high altitude pulmonary edema. A more severe component is HACE. If he was hallucinating, he was moving into that, which is high altitude cerebral edema. Okay? Now, the closest I've come to it is nausea, diarrhea. I've gone hiking with my husband when we were dating. We were in the mountain wilderness area up near Tahoe, and that's less than 8,000 feet. And we had climbed, I probably can count on one hand the number of times I've gone backpacking, and we backpacked in, and then the next morning we had about another 200 feet in elevation to climb to the pass.
Was that the Pacific Rim Trail? Because that's about 9,000 feet.
I'm not sure
If it was
whether it
on
was
the- if it
March.
was on the western side of